So let's start understanding four topics today. Not four topics, I mean, we are just gonna understand types of cell, okay? Cell type. And in cell type, we're gonna understand labile, what exactly is labile, why it is labile. Then we'll understand what is stable, okay? What is stable cell? Then we'll understand something which is called permanent. Okay, so we have three type of cells. Okay, let's start with basic ones. Now before even starting, I want to create a sort of understanding. Okay, so what we're gonna do first thing that we're gonna do is that we're gonna understand why do tissue regenerate. And first of all, what is regeneration? We'll understand. Then we'll understand what is recycling, right? We'll understand what is recovering, and then we'll answer some heavy questions such as why do tissue regenerate at different rates, right? We'll understand cell cycles, right? And we can understand these phases, G1, G2, G0 phases. And then once we understand the basics of this topic, we can ascend to the type of cells, right? Like labile, stable, permanent, right? So let's start with, first of all, let's define what exactly we are gonna talk about, right? Now I want you to close your eyes, and I want you to cut yourself, not like harm yourself. Just I want you to imagine, go on this imagination trip with me, right? If you will cut yourself, what's gonna happen is that your skin will heal, right? And you'll be okay. Now the important question is that why it even happens, right? Why it happens. But if you have some sort of scar, right? Now imagine if you lose some heart muscle after some myocardial infarction, you do not regenerate. Instead, you have a scar tissue. Now why? Is it because the heart cells are just bad cells, weaker? Well, all of this, crux, the answer to this question actually lies in cell cycle. Okay, so let's start with cell cycle. So what the hell is cell cycle exactly? Let's start with absolutely zero. Okay, we'll start with foundation. So we have one cell, and then it becomes two cell. This is exactly what cell cycle is. Okay, for example, skin cells are like rubbed off, right? You eat a lot, and then your intestine cells are getting damaged by the acid, right? By the intrinsic acid you have, by the food itself, by the enzyme, by the bacteria. So they have to divide again and again. Your blood cells, right? Your RBCs have a lifespan of 120 days, so they die a lot, and then you have to make new blood cells. So eventually every tissue in your body is going to disappear. So that's why your body has to continuously replace the lost cells, right? So one thing I want to ask myself as I am discussing about this topic is that could every cell simply divide forever? Can a cell simply divide forever? That's a good question, right? The answer is no, because if a cell is gonna divide forever, it's practically immortal, right? So no, that's not gonna happen. Then how do we decide? How do cells even decide when to divide, when not to divide, right? Different cells have different jobs. I want you to think about a neuron. A neuron forms thousands of these specialized connections, right? Now, if it starts replicating, if it starts dividing, these connections would have to disappear, right? And that would destroy the whole neural network, right? So specialization often comes with the cost of losing the ability to divide. So what I'm trying to say is that we have a trade-off. The trade-off is if a cell is specialized, right? If a cell is super duper specialized, it's not gonna be very much regenerative, okay? The ability to divide is gonna go down. Now, I'm giving you an assumption right now. I will tell you why it happens, right? This principle, if a cell is super duper specialized, the ability to actually divide actually goes down. This principle explains much of this whole topic of labile, stable, and permanent cell, right? Now let's talk about cell cycle, right? This cycle is actually this cycle tells you about how the cell actually divides. Okay, so I'm gonna make this everything, right? It answers one of the most important question, is that how does one cell safely becomes two genetic cells? Now I use the word safely here, okay? That is very important, because safely is the key that why cells don't divide, right? It's always about understanding the trade-off, because when you want to divide, you have the chance, you have risk of actually damaging your own DNA. So if you will damage your DNA, then I mean it's a risk, you know. So you don't want to damage your DNA. So let's talk about cell cycle, right? So how it really happens, right? So we have first phase, that is G1, then we have G2, right? Okay, let me make it again. G1, G2, again we have G1, and again we have G2, and then we have M. Okay, and between G1 and G2 we have S, and again between G2 and G1 we have again here M, right? And from G1 G2 we have S. It's a cycle basically. So cell moves from G1 to S, okay, then from S it moves to G2, and then from G2 it moves to M phase. Now you're like, Shashwat, what are you saying, M? Then from M it moves to G1, and then from G1 to S, then G2 to this one, and then this. So this is the cycle itself, right? Now you must be saying, oh, tell me about these words, these look so intimidating. This is how it actually happens, right? Let's talk about G1 phase first of all. Now what is G1 phase? G1 means growth, okay? So I want to ask you, why doesn't a cell immediately copy its own DNA, right? Because the DNA is already inside, right? This G1 phase is the phase where cell actually prepares, right? Because DNA replication is super duper expensive. It takes ATP to do this whole replication work thing, right? So it's dangerous. So first the cell wanna be like, oh, do I have enough nutrients? Is there enough energy? Am I damaged? Maybe I should divide. Maybe I should not divide. So these are the questions the cell has to first answer itself, right? Now if the answer is yes, then only it will proceed. Now I want you to think G1 as a decision point, right? So G1 is when the cell thinks, should I do it or not? Then we talk about S phase. S is the synthesis phase. Synthesis of what? The DNA, okay? So S stands for synthesis. Now what is being synthesized? DNA. Each chromosome is copied, right? Now you must be thinking, oh, what is chromosome? Okay, we'll come to it. Each chromosome, well, let me just tell you chromosome. What is chromosome? Chromosome is just when you have DNA lying around, you pack it up, then you pack it up a little bit more, then you pack it up more, and then you pack it up more, and then it turns into a chromosome, right? Chromosome is just packed DNA, in simple words, okay? So DNA, right? So in synthesis phase, the S phase, each chromosome is being copied right now, right? So before S phase, in the G1 phase, right, there is chromosome. Of course, we have chromosome, right? Now after S phase, what we're gonna have actually, we're gonna have a chromosome of an X shape, and okay, it looks like an X. Yeah, now it looks like an X. So after the S phase is over, the product will what we're gonna have is the X-shaped duplicated chromosome, right? So this is how it will look like inside your little envelope, okay? What envelope, by the way? This envelope has this. There is this envelope, right? Envelope is like a cover that you want to protect this copied synthesized product, right? What is this envelope made up of? You can ask me. Well, this is made up of lipid and lamin, or laminin. I don't remember. I said lamin, I think. So what happens is that we have these phosphate, PO4 minus, right? What happens is that there is an enzyme. It goes and it talks to lamin and it phosphorylate the lamin. It puts this charge on the lamin, right? What is lamin, by the way? Lamin is just this structural unit of this envelope, okay? So once you put these negative charge, the lamin actually repel to each other, and then what ends up happening is that this envelope actually breaks off, and then this envelope open, and then we can physically remove the chromosome, take them out of the nucleolus, and then do things with it, okay? Wow, we just went to this different territory. Okay, let's come back to the S phase, right? So let's come back, right? So the amount of DNA is now double after the S phase is over, right? But the chromosome number does not change yet, okay? We want to know that. Chromosome is still the same, okay? Let's come to the G2 now. Now, want to ask you something. Why not divide immediately after the S phase? S phase is over. You have 2 chromosomes, right? Why do you want to wait for G2? Just do it already. Because we want to check for errors, simply. Mistakes happens, right? So cell is trying to check like, oh, was DNA copied nicely? Is anything damaged? Is everything okay? Right? So this whole thing is done in this phase, okay? G2 is the quality control phase, G2 phase, okay? Let's talk about M phase. What is M phase? M phase is mitosis. Now, mitosis. What is mitosis? One cell becomes 2, right? Chromosomes separate, right? We have 2 chromosomes. Whoop, goes to this one, right? Cytoplasm also divide. Half. We have these 2 daughter cells. So this is M phase, okay? So that's M phase. That's mitosis. The separation shit is mitosis, okay? Okay, let's talk now about, so that's the whole thing, right? Now there's another phase actually. There's a phase called G0. Want to introduce you to this phase now, G0. Now we arrive at this is a very important concept, okay? Because if the cell cycle is from G1 to S, and then S to G2, and then G2 to M, where did this G0 come from, right? Where is this G0 in the equation? Now G0 is actually outside the cycle, right? Think of this cycle as a race, right? G0 is like just relaxing. I'm not participating in the race. The cell is alive and well and metabolically active, but it is not preparing to divide, right? When the cell is in the G1 phase, the cell is actually preparing to, divide. It's like, oh yeah, let's get up, guys. Let's go. Let's synthesize. G0 phase is the phase when cell is like, oh, don't need to do this. I'm going to relax, okay? So G0 phase is the cell is alive, cell is okay, it's metabolically all right, but it's not preparing to divide. That's very important word right there. It is not preparing to divide. That's very important thing right there. Okay, so I want you to think about 3 cells. We have a cell A, we have a cell B, and then we have a cell C. I just named them A, B, C. Now cell A sits on these G1, right? Cell G1, then S, then G2, then M, then again G1, right? Sitting in this phase. B cell actually stays in G1, then it goes to G0, right? And then back at G1, okay? And then we have cell C, just chilling at G0. Now, what the hell is happening? So this cell A is always dividing, okay? Right there. This cell is always dividing. This G0 to G1, from G1 to G0 again, this cell actually rests. Temporarily resting most of the time. And the cell C, actually, it's at this G0 phase. So it never divides, right? These are the cells. These corresponds to labile, stable, and permanent cells, okay? Exactly 3 categories on our title now, okay? So this phase, G0, right? Now let's talk about the main topic. What is labile, right? Now this labile is the cell that stays in G1, right? The cell that stays in G1 but never enters in G0. It never does it, right? Let me explain you now. It remains in G1. It means a cell A type, right? So when I say it remains in G1, it doesn't mean that they are stuck. It means that after mitosis, after M phase, instead of leaving the whole cycle and going to G0, it goes to G1 instead, okay? Immediately they begin preparing for another round, okay? So this is labile cell. They are like always, regenerating. So no resting, always cycling. They never enter into G0. The question here is why? Because these tissues are constantly losing cells, okay? Imagine some sort of intestinal epithelium, right? You eat, what's gonna happen? You're gonna have injury. Cells are constantly being shed, right? If stem cells rested, what's gonna happen? You will have problems in your intestinal lining. You can get seriously, ill. So they need to always divide. So there's a word called quiescent. This is a buzzword, right? A lot of people use them. Quiescent means resting. Okay? So they are not dead, they are just resting. They are not inactive. They are just not dividing. They are just resting at G0. They're like, oh, nice time they're having. So why we need labile cells? We want to think about tissue by tissue, okay? So we need these labile cells at gut epithelium because we eat a lot and we have stomach acid and we have pancreatic enzymes and we have bacteria and we have billion other things, right? What about these stem cells, right? Where are these stem cells of labile cells, right? Where are they? They are in something which is called as crypts. Now, what the hell is crypts? Crypts are these, for example, this is a crypt. I'm just giving you an example. That's how the crypt looks like. Okay, the crypts contain stem cells, right? They divide. New cell migrate upward. This is the crypt. This is the stem cell. They're like, okay, I'm gonna make some more intestinal epithelium go up. So this is how it happens, right there, right? So if they ask you which cells are destroyed by chemo, you wanna say crypt cell, mister. Then you'll be like, why it happens? Because chemo, right? Chemo and radiation actually attack what? This whole cycle, cell cycle. It can attack G1, it can attack S, it can attack G2, it can attack M, right? So that's why. What other location where we can have these labile cells, mister? Good question. Skin is labile, super duper, because you have UV rays all of the time, cell die all of the time, we need replacement all of the time. What about your hair follicles too, right? You pick your hair and then you have new hair next day, right? So growth requires continuous mitosis. This is very important. Therefore hair follicles have these rapidly dividing cells, these labile cells. Bone marrow, your platelets, your lymph, your neutrophils are constantly dying and you have new lymphoplatelets all the time. So bone marrow has to have labile cells in them, okay? Because it's very important, you're gonna die if your bone marrow is not labile, right? So bone marrow cannot afford any sort of G0 resting phase, right? What about other cells like germ cells? Sperm cells, right? Germ cells. Sperm production is it's like happening throughout your adult life, right? So this needs to have some labile cells, right? So these germ cells are labile cells, right? Now I already told you why chemotherapy targets labile cells, because chemo attacks these phases of cell cycle, right? That's the thing. Now, okay, so we understand these labile cells, right? Okay, cool thing. Why chemotherapy cannot, it's like side effect, side effect. What are you saying side effect? Chemo side effect is like, you're losing your hair. Wow, he must be on chemo. Now you know why someone on chemo loses their hair, because chemo attacks this labile cell cycle. So if you stop it, you lose your hair, right? So, okay, your gut crypts are done, your epithelial renewal is done, you can have mucositis, you're gonna have diarrhea, malabsorptions, your bone marrow is cooked, you'll have anemia, thrombocytopenia, you have alopecia, infertility because your germ cells are now cooked because of the chemo, right? Radiation also does the same, right? Radiation damages DNA. Cell attempting DNA replication are vulnerable because damaged DNA must be copied accurately before the division, right? So rapidly dividing tissue accumulate these great injuries, right? This is why chemo and radiation is highly destroy the labile tissues, right? Now, gonna ask you a question. Maybe a woman comes to you, she's undergoing chemo. What cells will be affected? Crypts, of course, because where are the labile cells? In the crypts, right? Now, when does this concept actually break, right? When the chemo concept breaks. The chemo concept breaks, are all chemotherapy or all chemo drugs cell cycle specific? No, some of them, they can specifically attack G2. Some of them can attack M. These are really nice chemo drugs, right? But they are not so common, so that's important. Okay, so we understand labile cells. Let's talk about stable cells. What are these stable cells, right? They're stable. You must have some idea what are these stable cells. Okay, so I'm gonna continue stable cells in the next video because I'm just a little bit tired. Actually, not a little bit, quite tired. So if you want to see the next stable and permanent part, just put a comment that, hey, put stable and permanent. I think you can understand basically what stable and permanent is, right? From these example A, B, and C, right? Stable, permanent is like, oh, I'm not gonna divide, like your heart cells, right? Or your neurons. Why they don't divide? Because they are specialized. If they start dividing, who's gonna pump your blood, right? So they are stable. They are permanent. What about stable? Stable is like this liver. 60% of your liver is surgically removed. What happens? They need some stimulus. So stimulus goes to G1 phase. Your cell is like, okay, have to divide. Your cell is resting at G0. Imagine your hepatic cells. And you are like, okay, let me just take some portion off. 60% of the cell eaten or removed. Okay, removed, right? That's a stimulus. Okay, so the cell is going to transition from G0 to G1. That's your stable. Permanent is just permanent, like neurons and cardiac. Who's going to think if your neurons start dividing? Who's going to do that work, right? That's important. Who's going to pump the blood? So they do not. So that's why the highly specialized cells do not divide a lot. They do little bit, like chronically, slowly, they do it. But it's not like, wow, next day you are born with new heart. No, it doesn't happen. Why it doesn't happen? It doesn't happen because who's gonna do the work if they stop, contracting? Because cardiac cells are super duper specialized. They conduct. First of all, they have these sarcomeres. This sarcomere, they contract, right? They push the blood. Second, they conduct electricity, right? They are insane. They are super duper specialized. If they start producing, other cells, like they start regenerating, who's gonna push the blood? No one. So that's the idea of permanent cells and stable cells. Okay, so that's stable cells. So basically, the whole concept actually, hangs on your understanding of this concept, which I just regurged. So labile is always recycling, right? It truly never goes to G0, right? Like which diseases? Gout, right? Not gout. What I'm saying, anemia, right? Alopecia, right? Chemo, radiation. Stable is they usually are sitting in G0 resting, right? They can re-enter into G1 after some sort of injury, like your hepatocytes, right? Other example I can give is renal tubular cells, right? There is acute tubular necrosis, ATN injury. You have hyperperfusion to your injury, to your kidney for like 20 minutes, right? Your patient is in AFib, and this patient is it has like the heartbeat of like 180, and your patient is going on AFib for like next 10 minutes. And what's gonna happen? Hyperperfusion. You're cooked. Your kidney's creatinine is like 2.1, already cooked. 80% 80% nephron lost, right? What's up now? What's up? Nothing. Your renal tubular cells can go back, okay, but other cells other than renal tubular cells, they do not regenerate, okay? Only renal tubular cells. Renal tubular cells regenerate, okay, when they are giving the proper stimulus, right? Permanent cells are like neurons, cardiac myocytes, right? Muscle fibers, right? They heal, right? They of course heal, but they heal by fibrosis. They don't have these this stem cell regeneration, right? They repair. Yeah, of course stem cells are there. I'm not saying that myocytes and these skeleton muscle cells, they don't have stem cells, of course, but they do not regenerate. They heal with scarring and with fibrosis, right? And they have lowest sensitivity to the therapies targeting these cell division, because these cells are not under in this they're not participating in this cell cycle. So that's why they're safe. That's why even if you're on chemo, your brain is going to be okay, your heart is going to be okay, right? The single thing I can tell you is that a tissue's regenerative capacity and its susceptibility to chemo or radiation are determined primarily by where its cell spends their time in cell cycle. Okay, if the cell is continuously in the cell cycle, that is labile, right, then it's gonna be cooked. Then you have problems with the chemo and radiation. If it's resting, right, but recruitable, like stable cells, right, if it's like, okay, I'm gonna stay in G0, and when I know, like, okay, I'm in trouble, then I can jump from G0 to G1, then we can call them stable, like hepato and renal tubular cells, right? But if the cell is like, I am never participating in this cycle, then of course we can call them permanent, right? We can solve most of this question with these just concept which I just researched. All right, so that's the concept simply. Bye bye. Wow, this looks like a mess.